Structures such as bridges, dams, buildings, and tunnels are designed to perform to certain engineering criteria. Continually, they withstand operational load fluctuations and outside forces such as environmental conditions, extreme heat and cold, wind, precipitation, earthquakes, storms like typhoons and hurricanes, as well as other natural or man-made events. Over time, aging structures may not perform to the same standard as new. Owners and managers of such structures, often high-value properties that impact the wider population, want to have the best oversight of their property in order to get the most from their investment and also to ensure the safety of users. As part of responsible property management and risk management, structural health monitoring, or SHM, provides owners and managers with the tools needed to make the kinds of informed and timely decisions that could greatly affect the lifetime of the structure or the safety of users. Structural health monitoring is the continual observation of a structure over a period of time to better understand its behavior. The motivation for implementing SHM as part of management optimization is that this is a way for a structure to tell the owner or manager how it is doing. The structure can't talk, but SHM can listen, and this is how we gain an increased understanding of the structural behavior. It can offer early detection before reaching a critical state. There is an assurance of serviceability. It can mean decreased downtime for inspection and repair. It can help with developing rational maintenance management strategies. It can bring increased effectiveness in allocation of resources. SHM can help with increased property value and perhaps decreased insurance costs. So, how does SHM work? Different sensors are installed in key locations. The size and shape of the structure will affect how many sensors would be needed and their locations. GeoSIG can help advise the best placement for sensors. In this example, for a box-shaped 10-story building, it is recommended that sensors would be installed at a minimum at basement or ground level, mid-height, and the top floor. At each instrumented floor, there should be a minimum of a biaxial and uniaxial sensor. The sensors detect exceedance of allowed performance criteria, as well as identifying and verifying structural behavior. SHM can detect changes in the characteristic features. This was the baseline, but it is now different. SHM will identify the location of suspected damage or aging and will issue notifications enabling corrective actions to be taken. Continuing with our building example, SHM continuously monitors the structure's performance parameters, which could include translations, displacements in the horizontal plane, such as a side-to-side movement of a floor, torsion, rotations in the horizontal plane, such as the twisting of a floor, thus its columns, interstory drift, when the building is shifting so that the stories are no longer aligned, overturning, when a rigid block tips. Each project's needs will determine the custom instrumentation setup. If there is a need for a siren or a visible alarm lamp, if there is a need for elevators to be shut down automatically, if there is a need for vaults to lock or doors to open automatically, these can all be accommodated. The sensors continuously measure the structure's behaviors. The data is analyzed by GeoSmart software. If there are exceedances, reports are made. If the exceedances warrant immediate action, alarms and alerts are sent. This would also trigger predetermined automatic actions. If the exceedances show damages, the data gathered by the sensors can help building owners or managers to make next step decisions. Should the building be evacuated? Should building inspectors be called to look at a certain area of the building? Will the building be safe to continue using in the meantime? Are repairs necessary? The information provided by GeoSmart will help inform these decisions. What SHM doesn't do. SHM is not necessarily going to detect sudden sinkholes or huge damaging earthquakes. It detects changes in the structure as they happen. It doesn't predict an upcoming event such as an earthquake or typhoon. The valuable data that SHM does gather helps owners and managers to make informed decisions for the maintenance of the building or regarding evacuation needs. Sometimes there might be undetected or invisible damage to a structure that would be overlooked, but this is where SHM really makes a difference. These graphs show the expected serviceability and maintenance costs of a structure as it was designed. Increased maintenance costs are likely down the line because the structure will age. This is expected. However, an unforeseen event might cause some invisible damage, in year 12 in this example. Without monitoring, no one knows the damage is there, so the damage continues. By the time the damage is visible, in year 28 in this example, it has become a very big problem with much higher repair costs, perhaps too high to be worth doing. In some cases, it could even lead to a catastrophic failure with potential human loss. The same scenario, but with monitoring. The blue line shows the non-visible damage was detected by monitoring, so the repairs were made much sooner. This has saved considerable cost and has extended the life of the structure. SHM enabled the owner to take action at the right place and the right time. So what are some of the benefits of structural health monitoring for risk prevention? SHM can monitor factors that eventually lead to failure. It can evaluate the severity and effect on the structure, initiate early damage detection, provide a reliable measure for decision-making. It can help people to decide to evacuate or shut down a structure due to a transient event, such as a typhoon or an earthquake. Reduce risk of disaster by notifications. And it can help save lives as well as assets. With some of the benefits of SHM for the management of the structure, it enables one to better manage and maintain structures, rapidly evaluate the structural response, fact-based understanding of in situ structural behavior, assure structural serviceability, development of rational maintenance and management strategies, decrease downtime for inspection and repair, increase effectiveness in allocation of scarce resources, decrease costs, significantly reduce insurance premiums, if applicable, increase value of the assets when compared to non-monitored properties, enable and encourage the reliable use of new and innovative materials and designs. Now we can take a look at instrumentation. We like to use the analogy of using structural health monitoring to listen to how a building is doing in the same way a doctor listens to a patient's heart or lungs. In both cases, the sensitive instruments can pick up any anomalies. So let's take a look at GeoSIG's instrumentation for SHM. For building SHM, one common solution is a distributed network, where GMS Plus digital recorders are paired with accelerometers. The size and shape of the building will determine best location for sensors. When looking at costs, cabling of the instruments is a factor, and this will help decide between digital or analog sensors in some situations. Another possible solution is to have a centralized recording system, like FORA, in place of GMS Plus. It has up to 36 channels, which means one FORA will likely handle all the sensors. It's capable of communication via Ethernet TCP/IP, internal landline modem, external GMS modem, external satellite modem, external GPRS modem, or external UMTS 3G modem. However, no project has a one-size-fits-all solution. GeoSIG wants to accommodate customer needs, so we've also developed a hybrid solution with digital sensor system, which offers some centralization and some distributed network. Depending on what is needed, we are able to find the most optimized instrumentation configuration to help our customer. Because we design and build our own instruments and software, we implement our own solutions using our own products, and we have the flexibility to make custom changes based on customer needs. We're always looking to offer a solution that is the best fit for the requirements. Another type of structure commonly monitored is bridges, which have unique monitoring needs. These are some of the important criteria that are of interest to us, and since there will be many users, it is important to know that a bridge is safe to use. Typical instrumentation for bridges would often include FORA as a central digital recorder, along with appropriate sensors depending on the project's needs. For example, SHM can keep an eye on cracks by utilizing strain gauges. GeoSIG can offer a solution that can encompass all types of sensors, which then give the necessary information to be able to monitor the health of the structure. Solutions often use accelerometers, meteorological sensors, displacement, tilt, and strain gauges as may be needed for the project. Here is another type of bridge, a cable-stayed bridge, which is instrumented based on its physical characteristics. SHM monitors elements of the bridge which are subject to change according to the loads they endure and the changes that may impact the bridge due to environmental conditions or natural disasters. The number of channels available with FORA makes it ideal for this type of project. However, there may be special requirements of the project that would call for a distributed network, and in this case, GMS Plus, or Sky, would be an option. GMS Plus recorders can be wireless or wired, which offers some additional flexibility. The recorders digitize the data so that it can be analyzed. In addition to our own designed and manufactured instruments, GeoSIG also has proprietary software, including GeoSmart, which is a graphical Java-based application that provides tools for real-time structural health monitoring for civil engineering structures. It can analyze the data coming in, calculate and plot the data, and show the changes in 3D animation, in surface views, and in 3D lines. GeoSmart will email reports and alerts in case of exceedances. Here you can see GeoSmart analyzing data. Different windows show the important items of interest. In this case, the channels as the data comes in, the frequency of incoming streams, the drifts and rotations, and the 3D model showing alarms in real time. It also is continuously calculating and saving the data. GeoSmart can animate the near real-time motions on the 3D model and can create visual alerts for incoming and/or calculated data. And once again, because this is our own software, we can make GeoSmart factory customizable depending upon project requirements. GeoSIG is a long-established manufacturer of seismic instruments, where over the years we have developed different solutions to be able to provide optimized hardware based on the requirements and the needs of the project for ease of installation and cost-effectiveness. Over 30 years, we have instrumented thousands of structures in more than 50 countries worldwide on all continents, for local governments, national institutes, and private companies. We have a very long list of installations, including in highly legislative industries such as nuclear power plants, for high-profile references, and highly sensitive and difficult industries. And they choose GeoSIG because we have prioritized offering high-quality products that are reliable and have longevity, because we make serious instrumentation that is used in important projects, and the data our instruments gather matter. So we go out of our way to make sure our customers have a solution that is the right fit for their project. In our own small way, we try to make the world a safer place. Thank you. Are there any questions?